Hello everyone, my name is Aditya Sanjeet Suvarna and today I'll be explaining the lab 3 which was done for COM 380. So upon going through the textbook and the slides, I understood the answers to these questions. First, what does it mean for an arc to be consistent? So it basically means that an arc is considered consistent if for every value of the first variable there is at least one value of the second variable that satisfies the constraint. Coming upon the second question, that is, what does it mean for a network to be consistent? It means a network is arc consistent when every arc connecting two variables is consistent, meaning that there is at least one value in each variable's domain that satisfies the constraints between them. For the third questions about the possible outcomes of the arc consistency algorithm, I found there could be three possible outcomes. First being the arc consistent network. This is a method successful for creating an arc consistent network throughout, which means that for each variable there is a compatible value in which the domains of connected variables for every value in its domain. Second is the empty domain, that is the inconsistency, which means the network is inconsistent if during the process the domain of a variable is reduced to an empty set and no solution is found. Third is the partial reductions, in which the variable's domains may be partially reduced in certain situations, but the algorithm might not be able to identify an empty domain, leaving each variable in a condensed but uniform range of potential values. For this question, the CSP was given below, and the question was if we could run our consistency. So given that the constraints are a not equal to b, a not equal to c, and a b not equal to c, and their domains were equal to true or false, b equals to true and false, and c equals to true and false. Since b is not equals to c, means they cannot have the same value when either b or c is an assigned value, it restricts the possible values for a. As a result, one or more values may need to be removed from A's domain to satisfy all constraints, leading to a reduction in A's domain. For this question, it asks uh, if our consistency finishes and all the variables have multiple values in their domains, which is guaranteed to be a solution. Why or why not? So our consistency does not guarantee a solution even if all variables have multiple values in their domains, while it ensures that each variable has at least one consistent value with connected variables. It does not check for global consistency, meaning all constraints may not be satisfied simultaneously. Thus, a value assignment that meets all conditions may still not exist, so our consistency alone cannot ensure a solution in a network. So I created this CSP in the AI space, and so this was the CSP graph that I made here. I added the variables a, b, and c with their domains true and false, and also the constraints like a not equal to b, a not equal to c, and b not equal to c. So when I solve this, So this was the problem solved, and I noticed that in option D, it was I mentioned that A will be shrinked, but here I see that C variable was shrinked first. So probably the prediction went wrong over there. So yeah, that's pretty much about it. Thank you.